All right, here we are with our combo circuit. I decided to do this in a second video because a combination circuit involves both a series and a parallel circuit. And it's a good idea to really have a good handle on those two different kinds of circuits before you try to do a combo circuit, which means part series and part parallel. Ooh, I don't know what I did there. There we go. Nope. Okay, here we go. So let's draw our combination circuit, and I'm going to be redrawing this a few times, but I'm going to start with my battery. I have R1 at 100 ohms, and then R2 at 200 ohms. And then parallel to that, I have R3, 300 ohms. So I'm using the same resistors or light bulbs and the same battery, 24 volts. But now I've got a combination. Now, how do I know that's a combination? If I think about the current comes out of the battery, flows through R1. There's no option for the current to branch off yet. But right here, there's a branch right there. Current has to decide. Some of it goes through R2 and some of it goes through R3. All right. So that branch, here's where it adds back together again. That branch tells me, parallel. Okay, back to the battery. So that means R1 is in series with a parallel branch. R1 is in series with a parallel branch. And the way to simplify this circuit so that I can solve it is to figure out what is the total resistance of the parallel branch. What is that? And then if I figure that out, I can basically turn this circuit into a series circuit. So I'm going to use what I know about parallel. 1 over R total, or R equivalent, is equal to 1 over 200 ohms plus 1 over 300 ohms. Notice I did not put the 100 ohm in there. There's no 100 ohms in my formula, and that's because the 100 ohm is not part of the parallel branch. The parallel branch just involves 200 and 300 ohms. So now if I do this on my calculator, 1 over 200 plus 1 over 300 plus 1 divided by 300. And I have to get rid of that parentheses. There we go. I get 0.0083, 0.0083 repeating. And that tells me the total resistance is 1 over 0.0083, which is 120 ohms. So that means this parallel branch really offers the circuit 120 ohms of resistance. So I can go ahead and redraw that circuit as if the parallel branch is worth 120 ohms. So I draw my battery. 100 ohms is here, 100 ohms. And now I have a parallel branch. Let's call it R parallel, RP. It's really worth 120 ohms. Okay, and this is R1. And I have my voltage, 24 volts. All right, now remember, the goal is to find the voltage across every resistor, the current in every resistor, make sure that I can find I can add correctly to find the voltage that's provided by the battery, and make sure that the total current adds to the current provided by the battery, not I by the battery. And then I can use the voltage for the battery and the current that runs through the battery to find the power that's provided by the battery. All right, so that's really what I want to do, is find the voltage and current in each resistor. That's considered solving the circuit. So here I am, I've got this. Now, this looks like a series circuit, and it is. All right, current comes out here, flows through 100 ohms, flows through 120 ohms and back to the battery. So now I can pretty easily tell that the total resistance in the circuit is 100 plus 120 or 220 ohms. And that gives me a way to find the total current in this series circuit. It's going to be V divided by R, 24 volts divided by 220 ohms. I'm going to do that on my calculator. And I get 0.109. Let's round that to 0.11 amps. Okay, so I'm going to label that here, 0.11 amp. 0.11 flows through R1, 0.11 flows through the parallel loop, the parallel branch, 0.11. All right, now let's think about that. Going back here, 0.11 amps. 0.11 amps flows through R1 and then it branches. So some of that 0.11 amp goes through R2 and some of that 0.11 amp flows through R3 before it adds back together again. I still need to figure out I2 and I3. I don't know exactly how it divides. I know that R2 and R3 get some of the 0.11 amps of current. I just don't know how much yet. So the way to figure that out is to actually use the voltage. Now remember that R1 gets some of the 24 volts, and I can figure that out. V1 is equal to I R1 using Ohm's law. Okay, V1 is equal to I R1. Well, I is 0.11 amp, and R1 is 100 ohms. And if I multiply 0.11 by 100, I get 11 volts. So R1 takes 11 volts of the 24. So how much is left for this parallel circuit, or it's the parallel resistor? How much of the voltage is left? If R1 takes 11 volts, RP ought to take about 13 volts. So let's just check that. And let me get rid of this here to give myself some room. There we go. Okay. So I would like to find the parallel voltage. So that's going to be the current that flows through that parallel branch. And I know that that is 0.11 amp times the resistance there, 120 ohms. 0.11 times 120 gives me 13.2. I'm going to round that to 13 volts. Voltage parallel. All right, 13 volts. So 13 volts. What does that mean? That really means up here that both of these R2 and R3 get 13 volts. If I were to put a voltmeter here, the parallel branch gets 13 volts. 13 volts. Each of those resistors is going to get 13 volts. And this resistor gets 11 volts. And 13 and 11 add to 24. So back in my table, I can say, okay, V2, 13 volts, and V3, 13 volts. Well, now I have a way to find the current. And I've already got the current in I1. That was 0.11 amp. So I2 is going to be 13 volts divided by the resistance. How much resistance was there in I2? Or in R2 rather? It's 200 ohms. 13 volts divided by 200 ohms. 13 volts divided by 200 ohms, and I get 0.065 amps. And what about I3? 13 volts divided by 300 ohms. 13 divided by 300, 0.043 amps. If I add these two currents together, I ought to get the 0.11 amp. So let's try that. 0.043 plus 0.065 and I get 0.108, which in fact is 0.11, pretty close to 0.11 amp. So the current in resistor 2 and the current in resistor 3 need to add back together again after this branch, add back together again to get the total current that's provided by the battery. All right, so in my table, I've got V1, 11 volts. I've got V2 and V3. They both have 13 volts. And if I add the 11 volts and the 13, I get the 24 volts provided by the battery. But notice I'm not adding 13 twice. Resistors in parallel have the same voltage. And in this case, that voltage happens to be 13 volts. What about the current? Well, the current through the battery and through the first resistor is 0.11 amp, and then it splits into two parts. The second resistor gets some of that, and the third resistor gets some of that. And the bigger resistor gets the smaller amount of current. That kind of makes sense. But if I add these two currents together, I do get the 0.11 amp. 0.065 and 0.043 give me the 0.11 amp. 0.11 amps are provided by the battery. Last but not least, in this combo circuit, how much power is provided by the battery? Power is I times R. So the I is 0.11 amps. And power is not I times R. Power is I times V. I times V. I times V. Current provided by the battery, 0.11 amp. Voltage provided by the battery, 24 volts. 0.11 times 24. And I get about 2.6 watts of power. All right, provided by that battery. So that is how to solve a combination circuit. I will give you one combination circuit to practice this week. Have fun. You can certainly email me with questions, and if it makes sense to set up a Zoom for individual people who might have a question, I'm certainly happy to do that. I'm around every single day, but on Friday I will host a group Zoom, so you can log into that and ask any questions that you might have. All right, I'll talk to you later. Bye.